Hi everyone, welcome to my video. Hi friend, welcome to my video. If you have been following my previous video, you know that I am doing a course on UPSC previous year's question paper. So in this video, I will discuss civil service men's examination papers 2 optional physics on physics optionals. So one by one discuss question only, not to provide solutions. So which question asked previous year's 2022? So wait and watch. This is the physical constant which may be needed. So section is here. What is the Bernoulli concept of the meter? Evaluate the de Broglie wavelength of helium at a helium that is oscillated through 300 volts. Given the mass of the person, mass of the neutrons, sorry, given the mass of the protons, mass of the neutrons, 1.6 into 10 to the power minus 27 kg. And question number B is here. An electron is one-dimensional infinite potential wall defined by Px equal to 0 for minus A is less than x is less than A for Vx is equal to infinity. Otherwise goes from n is equal to 4 to n2 is equal to 2 level and emit photons of the frequency 3.43 into 10 to the power 14 hazards. Calculate the width of the walls. Assume the Planck constant h equal to 6.626 into 10 to the power minus 13 joules second and mass of the electron m is equal to 9.11 into 10 to the power 13 kg. And question number C is here. Calculate the magnetic field strength required to observe the NMR spectrum of protons in a benzene at 120 megahertz. Give the value of the nuclear G factor Gn of the protons. Proton is 5.585. And question number D. So that the legend G factor for pure orbital angular momentums and pure spin angular momentums are 1 and 2 respectively. Further elevate the G factor of the state P1. And question number is here. The rising J plus and lowering J minus operator are defined by J plus and Jx plus minus Ij. So iota Jy. So J minus Jx minus iota Jy respectively prove the following identity. This is proved commutation relation. This is not commutation relation but similar. Question number 2. Set up the Schrodinger wave equation for one-dimensional potential barrier and obtain the probability of tunneling. And question number B. So that En is equals to less than B greater than in the stationary state of the hydrogen atoms. And question number 2C. So that for given principle of quantum number n, there the n2 possible state of the atoms. In question number 2, an atomic state is denoted by 4d5/2. Find the value of Las and J for this state. What should be the minimum number of electrons involved that suggests a possible electron configurations? And question number, what is the speed wave function for s equal to 1 or 2? Spin the component in the direction of unit vector and zeta is equal to zeta has a value of 1 or 2 h cut. And question number 3b. What does the Stern-Gerlach experiment enjoy so much importance in atomic physics? Draw the schematics diagrams, schematics of the experimentals and comment on the shape of the magnetic pole species. What was the atomic beams were used in the experiments? And question number 3c. Define the Frank quantum principle. How does it help the explaining the intensity distribution of a vibrational electron spectra of diatomic molecules? And question number 4b. In a diatomic molecule, one constituent atom is replaced by one of its heavier isotopes, what change takes place in the rotational spectrum? Calculate the change in a rotational constant B when hydrogen is replaced by deuterium in the hydrogen molecules. Draw the spectra of the rigidity and non-rigidity rotors by using the systematic representative of rotational energy levels and comment on it. So this is comment. So write comment 5, 10 comment. Question number 4. Verify explain the effect of anharmonicity on the vibrational spectra of the diatomic molecule. Question number 2. Calculate the average period of rotation of HCl molecule if it is in the z is equals to 3 state. The internuclear distance and the momentum of inertia of HCl are 0.127 Newton meters and 0.0264 into 10 minus 14 kg meter square respectively. Obtain the normalization eigen factor of sigma x and sigma y matrix. And section B is here. If the nuclear force is charge independent and neutron and proton for a bound state, then what is there is no bound state for two neutrino? What information does this probe on the nucleon force? And question number 5b. Explain the each of the following particle cannot exist according to the quark model. Quark model. A bryons of sp1 and anti-bryons of electric charge plus 2. And explain the type 2 semi superconductor is better than type 1 superconductor in the application of the superconductor magnetic. So this is very easy. And question number D is, what is the field effect transistor called a unipolar transistor? Discussion how it is superior of bipolar junction. This is also very easy. And question number E is here. What is AND or NOR gate are called universal gate? Give the logic diagram, Boolean equation and the truth table of XOR gate. This is also very easy. And question number 6 is, so that for a specific value NL, the exit of the large distance related to the energy characterized by the quantum number n. Find the cell closures and the magnetic number predicted by the harmonic oscillator potentials. And question number B is here. You see the question number 6b. Consider atom hard uniform sphere. Find the number of the atom per unit cell and packing fraction for a simple cubic BCC and FCC. This is the solid state parts. And question number 6 is, write down the Weizsäcker's semi-empirical mass formula. Explain the each of the term. Explain why uranium 92 238 nuclide in a alpha emitter and not a beta emitter. Question number 7a. Explain the drawbacks of Einstein theory of specific heats and how it was overcome of Debye. So Debye is TQ and Einstein. So difference of what is difference about Einstein theory and Debye theory? So Einstein theory of specific heats of solid and Debye theory. And question number 7b. A neutrino and protono. This is question very easy. And question number 7b is, a neutrino and proton undergoes radioactivity capture at rest. Find the, so this is n plus p by d plus gamma. Find the energy of the photon emitted in the capture. It is the recoil of the neutron's importance. And the question number 7c is 7c. So zoom out. So this is, so question number 7c. Compare the dependence of the resistance on the temperature of a superconductor with that of the normal conductor. Describe the briefly or verify the formation of copper pairs. Question number 80. So that for a n-type semiconductor, the Fermi levels lie midway between the donor state and the conducted band is at a lower temperature. Ajo means EB is equal to 0. And the question 8b is here. The wavelength of a prominent X-ray lens for a from a copper target is 0.1512 meter. The radiation when diffracted with 100 plane a crystal with FCC structure corresponded to a back angles of 20.2 degree. If the density of the crystal is 2698 kg per cube and the atomic weight is 26.98 kg k moles, calculate the Avogadro number. And the question C is here. 8C. So right, which of the following decay are allowed and which are forbidden? If the decay is allowed, a state which is the instruction is responsible. If it is a forbidden, a state which conservation's law it occurs would violate. And so this is question, this question, this question, this question, this question. So that is all related to this discussion it for today. Thank you very much. On this I would like wish all students very good of luck for with the UPSC preparations. So thank you very much, my friends, my colleagues.